goal was to build what is called a zkSVM rollup settled on Solana. This has been done by Praedico, Stanislav, and myself. So a rollup is a blockchain that is derived and verified on another blockchain, in this case on Solana. So the high-level overview of the system that we want to build is that we will have users send transactions to the component called sequencer, which takes transactions, orders them, and builds a block that is then sent to a component called the zk program that will run complex mathematical operations to generate a proof. This proof is then sent on-chain to the on-chain program that we call the zk bridge, which will run the verification of the proof and update the view, the local state, let's say, of the rollup. Then any RPC node for the rollup will be able to look at the on-chain program to update their local view of the blockchain to update the state of the rollup. So what we actually implemented during this program is the on-chain verification program and the zk program that verifies the execution of SVM transactions. And I'm going to give a little demonstration of how that works. So zk proofs take a lot of time to generate, so we had to pre-generate a test sequence. In our case, the test sequence is that we will have two participants, A and B, but that both start with 10 SOL. A will start by sending 1 SOL to the rollup. It will then call an arbitrary program, in our case, a simple counter program on the rollup. It then sends half a SOL to B, and B will be able to withdraw that SOL from the rollup to the mainnet, the Solana mainnet. So I can just run the tests. And so we see that the initial balance is effectively 10, as we said. And the final balance is that A has spent 1 SOL sending it to the rollup. He has 0.5 SOL left on the rollup, and the receiver has so 10.5 SOL on mainnet, which kind of proves that what we expected the state to be is correct. So we are able to execute arbitrary SOL transactions on the rollup, although there are some limitations that we still need to work on, but this kind of concludes the presentation for the zkSVM rollup. So I also participated in the research cohort, and I chose to write on a topic called that I entitled Ember, which stands for Auction Managed Based Efficient Rollup. So rollup, as I previously mentioned, are blockchains that are derived and verified on another blockchain. In the previous presentation, I presented the verification that uses zero-knowledge proofs. In this case, I'm going to focus on the sequencer component, which is another very important component of rollups. And right now, current sequencers that exist are either very centralized, completely centralized, and you have to pray that they don't rip you off and try to maximally exploit you, or they are very decentralized and it can create inefficiencies, bad UX, and also leaves you victim of a lot of MEV. So what we want to do with Ember, what I want to do with Ember, is to introduce an auction mechanism where the top bidder, the sequencer that has the highest bid, will become the sequencer, but has to pay a rent to the rollup user. So in this paper, I first go over the advantages of rollups, the related works in terms of sequencing, how the state-of-the-art sequencing works, before first giving a high-level overview of the Ember mechanism and how Ember would fit, for example, in a zkSVM rollup, for example, before diving in the more specific components where Ember contributes. I then explore some of the cases, the strange cases that can happen during sequencing with Ember, and then discuss some interesting, let's say, side quests of this sequencing method. And since this work is part of the research portfolio, it also comes with its blog post that tries to distill the learnings, the knowledge of the article into something more approachable, let's say. And there's also even a TikTok style video that tries to be funny and dynamic to really make the viewer understand the problematics behind Ember, the problematics that Ember tries to solve. And I will share all the links. Thank you for your attention, and moving on.
Yeah, brilliant work. Brilliant work. Your efforts over the last few months have been very, very inspiring and have caught notice of a lot of people in the ecosystem. And it's really just hard work. It really is just hard work.